Hi, I'm Dave Baring, Technical Director at TriStar, and welcome to Tech Talk. Today I'm going to talk briefly about extreme materials for extreme conditions. If you've listened to our High Performance Materials seminar, we talked a lot about these particular materials, so this is going to be kind of a quick hit on materials that you should look at if you're looking at some very extreme operating conditions for your application. And there are some very basic guidelines that put us into the extreme category. And by extreme, we're talking about the materials that, number one, are the most expensive materials. Number two are the materials that are going to give you the best overall performance if you have conditions that fall into these categories. The first one being temperature. Materials that are classified as extreme materials are materials that typically are going to be used in applications in the 350 degree and up range. And that includes materials that will take us all the way up to 800 degrees. So temperature is really the first driving factor when you look at extreme conditions. Secondly is chemical resistance. Most of the extreme materials are capable of taking some pretty extreme chemical exposures. Obviously, the best one is the PTFE-based materials like Rulon and fluorescent. So if you have a chemical situation on any part of the pH scale, these are the materials that typically are going to be the go-to materials, especially if it's combined with high temperatures. Next is certain electrical applications. Some of the high-performance materials in very harsh electrical environments where there's very specific dielectric needs, and that can be in terms of dissipation factors, it could be in insulative factors. All of these things can come into play. And again, the driving force behind this would be the temperature. Are your dielectric issues also in an environment where temperature can be an issue? With these new very high frequency electronics and microwave applications and things like that, some of these high performance materials are key to performing in those environments. Physical demands. All of these extreme materials fall into the category of extremely strong. Their tensils, their compressive strengths, their flex modulus, their flex strength, all of the physical characteristics of these extreme materials are at the top end of the plastics world. Some of these materials are being used on a regular basis to replace metal because there's a weight savings by going to these plastics, and you get the weight savings without losing much in terms of strength value. There are some materials that will have as high as a 7-to-1 strength to weight ratio compared to a metal. So in conditions where physical strength is a key factor, these are considered to be the extreme materials, and it would be another factor that we would look at. Dimensional stability. All of these materials are going to have, with the exception of the PTFE-based materials, all of these materials have very low coefficients of thermal expansion. What that gives us is, number one, it gives us a material that has very reliable physical properties across a very broad temperature spectrum. It also gives us the ability to design closer tolerance parts, and that's especially critical in very close tolerance aerospace structural components. It's also very critical in bearing applications where we need to hold extremely tight tolerances on both press and running clearances. So dimensional stability, another main factor of the extreme materials. And then finally, wearability and frictional properties. All of these extreme materials have very good inherent frictional and wear properties. The addition of additives like PTFE, carbon, graphite, some of the traditional fillers that are used to enhance lubricity and also enhance things like physical strength, thermal properties. All of this is certainly within the realm of these resin systems. And again, we're talking about all of these factors being extreme in terms of plastics. They may not be extreme in terms of metals or even some of the composites that are out there in the market today. But for the plastics world, these materials would be categorized as extreme performers. They would also be categorized as extremely expensive. Again, looking at it in the spectrum of plastics world. So if you have applications where temperatures above 350, physical properties as far as strength are key, chemical resistance, wearability, low friction, dimensional stability, if these are the factors that you're looking for and you're looking to save weight, the extreme materials, as you see on our chart here, polyimide, PBI, which is the Cellazole material from Quadrant, Torlon, which is a polyamide imide, PEEK, your PTFE family, which includes the fluorescent, Rulon, Ultraflon, some other materials, and then finally PPS. These are the materials that we categorize as extreme high-performance materials. And if you have any questions about how these fit into the design world, give us a call. Visit our website. You can go to any of these materials that you see on this presentation and check out the physical properties. Or give me a call, visit our website, go to the blog site. Again, we have so many ways that you can communicate with us. We invite you to do that and let us help you make the right material choice for your application. Thanks again for joining us. We look forward to seeing you once again.